Okay, number 1. 8x, parenthesis, 6x plus 6. When you see a problem like that, what word pops in your head? Well, multiply or distribute. You can't FOIL. To FOIL, you have to be doing a binomial times a binomial. This is a monomial times a binomial. So we're just going to distribute. 8x first distributes to 6x. What is 8x times 6x?
8 squared.
48x squared. 48 because 8 times 6 is 48. X squared because it's x to the first times x to the first. So since we're multiplying, why wouldn't it be x to the first? Why wouldn't you do 1 times 1 is 1? Right, the rule is when you're multiplying variables, you add up the exponents. Okay, now we also have to distribute that 8x to the first times 6, and that gives us a positive 48x, and then you're finished. Yep. Okay, so now what I want you to do is circle the following problems. Circle number 2, 3, 5, and 6. Okay, because now that we've worked through number 1, you should be able to do 2, 3, 5, and 6 on your own. Okay, now let's look at problem number 4. Okay, problem number 4. 2k cubed, parenthesis, 2k squared, plus 5k, minus 4. Okay, what word pops in your head? Distribute again. We're going to do the exact same procedure, except for instead of a monomial times a binomial, we're doing a monomial times a trinomial. So our answer for this one was a binomial. What do you think our answer for this one's going to be? A trinomial. Okay, so let's start by distributing 2k cubed times 2k squared. What does that give you? 4k to the 5th power, because 2 times 2 is 4. When you multiply k times k, you add those exponents, and that gives you a 5. Then you have to distribute the 2k cubed times the 5k, and what do you get? Positive 10k to the 4th, right? A lot of students mess up there, and they'll put a 3. Why do you think they do that?
They don't think about, because it doesn't have nothing but a k. So
Right. They forget that this is a 1. Okay? Anytime there's no visible exponent, it's a 1. And so 3 plus 1 is 4. So if you're prone to forget those kind of things, maybe go and fill in those invisible ones before you start. Okay, then we have to do 2k cubed times negative 4, and that gives us negative 8k cubed, right? So just for practice, let's name this polynomial. What's the degree? What's the highest? Okay, what do we call that? Quintic. Okay, and then how many terms does it have? 3, so that's called a trinomial. So this is a quintic trinomial. What about the answer for number 1? What would we call it? It is a binomial, but what do we call its first name? Okay, what's its highest exponent? So that is... No, binomial means 2 terms. This is a binomial. But what is its name because of it being degree 2? Y'all, when we graph degree 2 polynomials, they make what kind of graph? A quadratic. It's a quadratic binomial. This is a quadratic binomial. Quadratic because it's degree 2, binomial because it's 2 terms. This is a quintic trinomial. Quintic because it's degree 5, trinomial because it's 3 terms. Okay, so now that we've done number 4, you should feel comfortable with 7 and 8. So go ahead and circle 7 and 8. Okay, now let's go down to the second section. Okay, number 1 in the second section says 3a squared cubed. Now, what all is actually cubed? Right, all of it. Since 3a squared is in parentheses, and the cubed is on the outside of those parentheses, that means all of this is you're just multiplying it 3 times. So this literally means 3a squared times 3a squared times 3a squared, right? Well, first let's deal with those coefficients. What's 3 times 3 times 3? 27. And that makes sense because isn't 3 cubed 27? What's a squared times a squared times a squared? A to the 6, because 2 plus 2 plus 2 is 6. You add the exponents. Now, pay attention so this doesn't confuse you. Remember, when you multiply variables, you add the exponents. Okay, but look, since all of this is cubed, I could have written this as 3 cubed times a squared cubed, right? Have you ever heard of a power to a power? You know how exponents are also called the power, like the power of 2, the power of 3? Anytime you have a power raised to another power, the rule is you multiply those. 2 times 3 is 6. So if you didn't want to write it out like this and add them up to get to 6, you could have just noticed that it's a power to a power, and when you look at it like that, you multiply. You see the difference though? Let's do one more like that. Let's do number 2. Alright, number 2, we have 2n to the 4th quantity to the 4th power. That means all of it's raised to the 4th power. Okay, so I'm going to raise 2 to the 4th power first. What's 2 to the 4th power? 2 times 2 is 4. 4 times 2 is, and 8 times 2 is 16. So 2 to the 4th power is 16. Well, what about n to the 4th all raised to the 4th? What do you do when you have a power to a power? Multiply, and you would have got n to the 16th. Now, had you written out 2 into the 4th times 2 into the 4th times 2 into the 4th times 2 into the 4th, you would have got the same thing. Because you would have added up those 4s, and they would have added up to 16. Okay, so now you should feel comfortable with 3, 4, and 5. So circle 3, 4, and 5. Well, we're about to do number 6. Alright, number 6. Right, we have 2 variables inside. 3ab to the 4th power, all raised to the 4th power. Well, if it's raised to the 4th power, doesn't that mean we're just going to multiply it 4 times? Okay, and you don't have to write it out if you understand the rules, but sometimes seeing it written like this just is easier. First, let's deal with the coefficients. What's 3 times 3 times another 3 times another 3?
No, it's something with a 1 at the end. I don't know.
Well, you have calculators. 81. Okay, because 3 to the 4th power is 81. Now, what about our a's? We have an a to the 1st times a to the 1st times a to the 1st times a to the 1st. A to the 4th. Because remember, guys, you're just raising everything in here to the 4th power. You raise 3 to the 4th power, you raise a to the 4th power, and you raise that b to the 4th power. What do you get when you do b to the 4th times b to the 4th times b to the 4th times b to the 4th? B to the 16th, because 4 times 4 is 16. Okay, so now we're doing one more. Let's do number 7. Okay, can I erase? Alright, number 7. 2 parentheses 2x raised to the 5th power. Okay, for this one, what is being raised to the 5th power? Just the 2x. So literally this means 2 times 2x times 2x times 2x times 2x times 2x. That's literally what that means, because this 2 is not raised to the 5th power, is it? Just all of the 2x's. So first just multiply those 2's. What is 2 times 2 times 2 times 2 times 2 times 2? 64. If you got 32, you didn't do that first 2. You just did the 2's for the x's. And then what's x times x times x times x times x? X to the 5th. Okay, and that was will be the final answer. So now you should feel comfortable with number 8. So circle it. Okay, so all the ones that we circled are the ones you need to try by yourself. Tomorrow we'll be going back to the packet, working more on binomial expansion with Pascal's triangle. Okay?